It's a meaty cup.
Oh.
It's
so meaty.
It's a meaty cup. Hold on, I'm going to show
So
you.
symmetrical.
It's unknown.
So unknown.
So unknown. Unknown. I wish I knew. I sort of can't even. I mean, it looks like. I know what it should be, but it doesn't look like what it should be. Look. Look at the meaty cup.
Oh, it's like a goblet.
It's a goblet.
Oh, it's a goblet.
Do you see the green?
Beautiful.
Do you see the green?
Yeah.
The green rim?
Yeah.
Look at that, it's got a green rim.
It's shaped like a goblet, though. It's beautiful.
It's easier without sun.
Oh, it is easier without sun.
That's amazing.
So meaty. Has to do with the incredible species of fungi there are in Tierra del Fuego, and the glorious nature of the forests. Just the fall colors, the healthy, pristine, old-growth forests that we can find here give us a snapshot of what the whole island would have looked like many years back before industrial deforestation.
It's totally outrageous to be working with this team in this location. It is so extreme. The biodiversity is unlike anything I've ever seen before. The team is so aligned in advocating for the protection of these organisms.
On this trip, we're combining different approaches. We're taking soil cores for SPUN, which we'll analyze for mycorrhizal fungal DNA. And we're also taking mushroom collections. So we're looking at both the above ground parts of fungal life and the below ground parts of fungal life. And this will give us a more complete picture of the fungal diversity in this area. And this will allow us to better understand this ecosystem, to understand how all of the organisms here work together in and around each other.
On every pixel of Earth, we are sampling soil and extracting the fungal DNA, which we will sequence to know which mycorrhizal species are right here.
I get the question a lot, why fungi? People are always asking, why concentrate on fungi?
I see them as as connective organisms that create the conditions for so much of the world around us. So all of the plant life that we see, all these plants depend on fungi. They depended on fungi to move onto the land. There wouldn't be soil without fungi that creates the soil. If there were no fungi, then wood wouldn't rot. The nutrient cycles within which we live and which power the biosphere and which support the lives of animals like guanacos, that support the lives of birds that we've been seeing here. They are driving so many of these fundamental biogeochemical processes that are vast and ancient and hard for us to notice because they're so big, they make us dizzy. But when we're here and we see them all together in these astonishing places, we see the mountains coming into the sea, we see the places where glaciers were, it's easier to become aware of them, and that's been really powerful.
It's such a huge task to make invisible organisms of global importance, and how to show that something that's invisible, and communities, whole entire communities that are driving these ecosystems that are under each footstep of ours, really are worth protection, are worth acknowledgement, appreciation. It's a large task we have of showing the invisible and putting it into the context of what you were saying of the sustenance of the biosphere.
I think many people haven't glimpsed into the underground world, and there are some scientific tools now that allow us to see for the first time how these fungi stitch together, the soil stitch together ecosystems and move nutrients. And that's really powerful, making the invisible visible. People become excited, they become aware of just how much life there is underground.
Oh, well, when the camera's off, I can tell you about that.
Whoa! What is that?
What is that?
Wow, that is like hormonal. That's rich.
It's rich.
That is a rich.
Merle, what is that?
It smells like the ass of the world.
So we've reached the end of the road that goes to Yendegaia National Park. It's the southernmost I've ever been in the world. I'm really excited, and we're in this incredible Nothofagus forest that's just in the perfect day of the year to find fungi. They're everywhere. You can't walk without stepping on them. I'm so excited about what we're going to collect, and I'm so excited to understand who's living here, both above ground and underground. Some people say this is the end of the world, but what we see is actually it's just the beginning of the world.
$13, $14, $15. Okay. In the past, scientists were classifying the world in piles. Science was all about making these individual piles, and now what we're seeing is that it's all about how these piles are interconnected, how it's about relationships, and how it's about the way that organisms interact on a daily basis. And so that's why we can go out into a forest and see guanacos, and we can see the bird life and all the animals and all the plants, and start to tease apart those very complex relationships at which fungi in many cases lay at the base of.
And it's so hard for us to think like that because we like to think about individuals and neatly bounded cells, but really it's all about the co-creative force between these organisms, and we see that here, I think. What's the word?
A lot of people ask, why do we come to this, faraway land that's really cold, that has the 4 seasons in each day? And the answer is basically that the fungal diversity here is so unique because of the unique nature of the symbiosis between southern beech trees and organisms from the fungi. What we see here, we don't see anywhere else in the world.
A lot of the work that we do as scientists is ultimately sitting in front of a computer, and even when we're working in the lab, we live our lives in control of these organisms. They set the conditions, we give them nutrients, we have a very strong power dynamic. But when we come into the field like this, it's the other way around. The world is the tube and we're inside it, and I feel humbled every time this happens, and it really feeds my work to do this, to be outside with people that you are collaborating with, that you trust, that you play with, that you can laugh with, and be bodies in a wild, wet world.
So I can see them, the guanacos. are in the forest, and you can just hear them. They're running through the forest. They're the only camelids that live in forests. So you can just hear the sound of the guanacos, and it sounds a bit like a donkey.
High-pitched donkey.
It sounds like a high-pitched
donkey.
The forests in Tierra del Fuego have a special magic. When you walk into a forest in the heart of autumn here, you can hear the trees rubbing against each other with the wind blow. You can see the lichen dancing off of the branches in the trees. But the biggest of luck is when you have those days in the forest where you look at the forest floor and like there's a carpet of ectomycorrhizal mushrooms. Really, when you endure the cold, the wind, the snow, and you get to that beautiful sunny day with those mushrooms, you understand the magic of Tierra del Fuego.
We all bring different perspectives, we all bring different kinds of experience, and when we come together we can think in new ways together, we can strategize in new ways together, we can imagine in new ways together, and so it's so important to be here with them and to be spending this time in this incredible place doing this work.
I've seen things I've never seen before. I've heard things, I've smelled things. The world feels different when we are all together because we see things slightly differently and we're learning from each other. So working with the Fungi Foundation is such an incredible symbiosis with SPUN. It makes for a great team.
When we come to these forests, we see that the planet is very much alive, even in places that are suffering the hardship of climate change and others. It's important, I think, for us to send a message and to communicate that there's time for us to form a relationship with nature. Not all is lost. And there's time for us to still discover species, to understand that in those species and in how they live, we might find solutions that can help us move forward in this changing world.